Now we will calculate the pharmacokinetic parameters from this information. First, let's calculate the concentration at 0 time. As explained earlier, the intercept equals log the concentration at 0 time. So the concentration at 0 time equal 10 to the power the intercept. So here we will insert an equation equal 10 the power sign shift and 6, and then we select the cell containing the intercept and then press enter. This is the value of the concentration at 0 time, 149, and it has the same unit as other plasma concentrations, microgram per milli. Next, we will calculate the elimination rate constant. As explained earlier, the slope equals the elimination rate constant divided by minus 0.303. So the elimination rate constant equals the slope multiplied by minus 0.2303. So we will insert an equation equals slope, select the slope, the multiplication sign minus 0.2303. This is the value of the elimination rate constant. The elimination rate constant has the unit of time minus 1 and the same unit of time used here to the power minus 1, so power minus 1. We then calculate the volume of distribution. The apparent volume of distribution equals dose divided by the concentration at 0 time. So Vd equals dose, and the dose was in this case 1000 milligram. Let's assign a specific cell for the dose, 1000 milligram, and then calculate Vd in the next cell. Vd equals dose, and since dose here is in milligrams and the plasma concentrations use a mass, the mass part of the unit is in microgram, we should multiply this value by 1000 to convert milligrams to micrograms, and then divide this dose by the concentration at 0 time. This is the volume of distribution, and it has the unit of the volume part of the concentration, so milliliter. The volume of distribution is often expressed in liters rather than milliliters. For this purpose, to convert it from milliliters to liters, we divide this value by 1000. So we can write it here to insert a new equation equals this value selected and then divide by 1000. This is the volume of distribution in liters. Now we calculate the elimination half-life. The elimination half-life equals 0.693 divided by the elimination rate constant. So we insert an equation here equals 0.693 divided by the elimination rate constant. This is the elimination half-life, and it has the unit of time, hour. Then we calculate clearance. Clearance equals the elimination rate constant multiplied by the apparent volume of distribution. So insert equation equals the elimination rate constant, the cell C18, multiplied by the apparent volume of distribution, and I would prefer to use the value in liters. This is the clearance. The clearance has the unit of volume. We use here the volume in liters divided by time. Now we have calculated the main pharmacokinetic parameters from plasma concentration versus time data using Excel. This represents the pharmacokinetic parameters after intravenous bolus administration.